All right, guys, we are going to work on one-step inequalities, adding and subtracting. And the thing about these, they're like equations, okay? So we're going to balance it like we would in equation, and we're going to remind ourselves inequalities are comparing two quantities, okay? So we're not going to do examples right now. We'll do that first. So some things to remember. We have our number line, right? Going to the left is negative, going to the right is positive. But I want us to remember, and we did this in our other notes, but it never hurts to have it in multiple notes. Our circles, so less than is an open circle, and less than, fewer than, some phrases that go with it. Greater than or more than is an open circle. But less than or equal to, no more than, a maximum of, at most, these phrases all mean less than or equal to. But when we are drawing, writing this inequality on a graph, we are coloring in the circle because the actual number that we're landing on, let's say no more than 2, it could be 2. That's why we're going to draw a circle and color it in, because it includes that number. It's inclusive. Same thing with greater than or equal to, but we also have no less than, a minimum of, or at least. Okay, so we're going to write an inequality with each situation to kind of review from our notes the other day. So there were more than 65 people, P, in the restaurant Saturday night. So the number of people, P, was greater than 65. And if you're not sure, you can always go back and look up at our notes. Greater than, okay? And we're just writing the inequality. We're not going to graph it yet. There were no more than 25 cookies in the jar. So we're going to say C for cookies. Look for no more than. We have less than or equal to 25, which means the number of cookies, you could have 24 cookies, 21, 2, you could even have 25, but you couldn't have more than 25. The bank required a minimum of $15 available in each checking account. I'm going to say A, account, okay? And then a minimum of. So a minimum of means you must have at least, it's greater than or equal to. So you have to have a minimum of $15. Okay? And then less than 5 people failed the test. So people less than 5. So less than 5. It didn't say 5 or less, it said less than 5. Moving on. So this time we're going to write a statement to represent the inequality. So one thing we need to know, looking at that. So my number is greater than 3. Okay, so write a statement. So we're going to say X. I don't like X. We're going to say N for a number. So remember, X looks like a multiplication symbol. So my number, as you see, it's getting bigger than 5. So it's 3 is greater than 3. And remember, my circle is not shaded in, so it's not greater than or equal to, it's just greater than. Then here, my number, so now is getting smaller, so it's less than or equal to 5. Okay. Here, my number is, we're getting bigger, so it's bigger, and it's filled in, so greater than or equal to, and the number I'm over is 2. And then here, my number is going smaller, so it's less than, and the number I've got my circle over is 1. N is less than 1. So now we're going to graph some more solutions, graph the solution set for each inequality. We did this on our other notes, so this is more practice. So as I said before, put your number on the number line, 7. I put it in the middle. Less than. Open circle, because it's less than 7, it cannot be 7. So my arrow points, no. Less than, excuse me. We're going this way. 2 is greater than or equal to x. So 2 is greater than or equal to. So we're going to draw a shaded in circle. And we said it's greater than or equal to x. Now, one thing I want you to look at is you see where I had x was less than 7, I have my variable on the left. So if this confuses you, where your variable ends up on the right, you can rewrite it with your variable on the left, like this. So I'm going to write my variable, write my constant. And then I'm going to flip the direction of my inequality. It's pointing at the x. It's still going to point at the x or equal to. So if you see, I just switched everything. My variable and constant switched, and I switched the direction of my inequality, so this still proves true. So now it says x is less than or equal to 2. So we're going to go this way, okay? So you could do this if you want. I like to do it because I get confused. I'll just be honest when I'm reading these, so I like to put it in that order. X is greater than 4, so 4 greater than is an open circle, and greater than goes that way, okay? X is greater than or equal to 10. 10 greater than or equal to 10, okay? Now we're going to solve inequalities. So here's the thing about solving inequalities. We're going to treat this like an equation. In this particular examples, like adding and subtracting equations. And we're going to pretend like our inequality is like an equal symbol. We're balancing both sides of the inequality. So when we learned our rules of adding and subtracting equations, we're going to balance it. So whatever you do to one side, you do to the other, okay? And we apply, so right here in our notes before, we have addition. The inverse is subtraction. So we're applying the subtraction property of equality because I'm going to subtract 5 from both sides to isolate my variable x. Remember, 5 minus 5 is 0, so I have x is greater than 16 minus 5 is 11. So once you have simplified your inequality, we're going to graph it. So I have 11 in the middle. Greater than is an open circle. X is greater than 11, so we're moving to the right. I have 18 is less than or equal to x plus 12. So I have addition again, so I'm going to apply the subtraction property of equality. Minus 12, and I have 6 is less than or equal to x. Okay, now if you don't like the direction, I don't either, I'm going to switch it, x, and this time my arrow is pointing at my 6, so I'm going to make sure the arrow stays pointing at the 6, so this still remains true. So 6 goes in the middle, and I have x is greater than or equal to, 6. Okay. Now I have 7 is greater than x plus 4. So let's simplify. I'm applying the subtraction property of equality by subtracting 4 from each side. So I get 3 is greater than x. So I'm going to flip it again. X is less than 3. So I'm going to come over here, put my 3, less than is open circle, and x is less than. There we go. And then my last one I have is x plus 15 is less than or equal to 19. Minus 15, minus 15, and I have x is less than or equal to 4, 4, and then less than or equal to is shaded in, and we're going to go less. Okay. And now we're going to continue to solve the inequality and graph the solution. This time we have subtraction, so I'm going to apply the addition property of equality, which is the inverse of subtraction. So I'm adding 8 to both sides. X is less than or equal to 21. So I'm going to graph 21 in the middle of my graph. Less than or equal to is a closed circle. And x is less than, so we're going to the left. 15 is less than x minus 7. Apply the addition property of equality. And I now have 22 is less than x. Now, if you don't like the way it's going, you switch it. X. My arrow is pointing at the 22. So 22 is still less than x. X is greater than 22. So 22, open circle. Okay, one more page. Let's do this. And two more. X minus 6 is less than 8. So simplifying, applying the addition property of equality, but adding 6, not 8. X is less than 14. So come over here, graph 14, open circle, x is less than. 2 is less than or equal to x minus 10. Applying the addition property of equality is plus 10, plus 10. Okay, so now I have 12 is less than or equal to x, or x is greater than or equal to 12. Okay, so 12, close circle, and then x is greater. Okay, so we have 3 word problems. All right, Gary has $27 to spend at the arcade. If he spends $11.25 on food and drinks, write an inequality that represents the most Gary can spend on games. Okay, so we're going to say money he can spend plus 11.25, because what he's already spent, is going to be less than or equal to 27, and here's why. He only has $27, so he cannot go over that amount, but he could spend that up to that much. So we're going to apply the subtraction property of equality. Okay. And the amount of money he has for games is going to be less than or equal to $15.75. Okay, had a thinking moment. So Cindy has at least $32 more than Rebecca. If Rebecca has $29, how much more does Cindy have? So Cindy minus Rebecca must be greater than or equal to 32. So applying the addition property of equality gives me Cindy her amount of money is greater than or equal to 61. Okay, our last one, you do. Jake took $45 to the bookstore. If he spends $27 on books, what can he spend on lunch with the remaining money? Okay, so lunch, I don't want to use that. We'll say J. Jake plus 27 has to be less than or equal to 45 because he only has $45. So let's subtract that $27 he spent on books from both sides. And now he has, ooh, so much money. Hope he's not hungry. So now Jake, his lunch money is less than or equal to $12. Hope he's not that hungry. And that's it.